So this is the electric force lab, and I want to talk about it just a little bit to make sure everything's clear with regards to what you have to do. In case one, you've got two charges, two particles, A and B, and you need to find the magnitude and direction of the electric force that A exerts on B. And so to do so, of course, you're going to have to use Coulomb's law. And remember Coulomb's law, F equals K Q1 Q2 over R squared. This is the electrostatic force. K is Coulomb's constant. That's 9 times 10 to the ninth. Q1 and Q2, these are the magnitudes of the charge. So magnitude means essentially the absolute value of the charge. Okay, the charges are stated here. Notice they are lowercase q's because lowercase q's include the polarity. Capital Q's are the absolute value, don't include the polarity. And R is just the distance between them. So you have the information you need up here to go through and calculate the magnitude of the force between A and B. I'm confident you can all do that. And then you need to state the direction of the force that A exerts on B. So you'll choose the direction. And then when you get to part B here, it says without doing any calculations. Now let me just say, you can do the calculations if you want. There's no way I'm going to know whether or not you're doing them. But you don't have to get the answer. Once you've done A, you should be able to figure out B without doing the calculations. If you do go through and do the calculations, that's fine. But realize that you want to understand how you could figure it out without doing the calculations. So ask me about it if you need to, because that's going to be important for the test, but potentially important for the test. Now, case 2 is identical to case 1, except we've changed the polarity of one of the charges. So you can see that A has gone from positive to negative. The magnitude is still the same. It was 32 microcoulombs before, now it's negative 32 microcoulombs, so the charge magnitude is the same, but the polarity has changed. So then you go back through to determine the force and the direction of the force. But again, it says without doing any calculations. You shouldn't have to do any calculations to get the answer for case 1B and then for both A and B from case 2. Okay, you just need to think about the laws that apply here. Now, when you get to case 3, this is a little bit more involved. And I'm going to go through this one a little bit here. So you can see we've got 3 parts here. Ultimately, the goal is to determine the net electric force on particle E. That's the goal. And so part A starts with, okay, determine the magnitude and components of the electric force that C exerts on E. Well, C and E, for mine, these are repulsive. So that means that's going to be the force that C exerts on E. So you're going to need to go through. This is essentially a vector problem. First thing you've got to do is calculate FCE, the magnitude of the force between them, and that's just Coulomb's law. Okay? So FCE, the force that C exerts on E, nothing fancy here. That's all there is to it. Now let's look at some of the details. C, so I am going to actually put the values in here. So F, that's C is E. Okay, so K is 9 times 10 to the ninth. Okay. Q sub C. Okay, now the charge for particle C is negative 4 microcoulombs, but I'm taking the magnitude of the charge, so that's going to be, 4 e to the negative 6. Okay. And QE, it's also negative, but again, I put in the magnitude of the charge, so that's 3e negative 6. Okay. Divide this all by the distance between C and E. Now, the thing is, I don't immediately know the distance between C and E. You'll see here that I'm told that particle C is located at 0, 2. Okay, so the distance between here and here for me, this is 2 centimeters. And then I'm told that particle E is at 2, 0. So that tells me that this distance is 2 centimeters. So the distance between C and E, so this called it r squared. This is really the distance between C and E, so r sub C E. Okay, well, I've got to do 2 squared plus 2 squared. That's going to equal RCE squared. Okay. So 4 plus, that's going to be 4 plus 4, that's 8. Darn thing. Come on. Thank you. That's 8 equals RCE squared. Okay, so now I know what RCE squared is. That's 8. Okay. Now I should point out that's, I actually kind of did this a little incorrectly. Not the way I really want to do it. I did in terms of centimeters, but we need to convert to meters. So let me just quickly change that and do it in terms of centimeters. That'd be 0.02 squared. Apologies for that mistake there. But now, when I do that, I get 8e negative 4 equals RCE squared. Now I could solve for RCE, but I don't actually need RCE. I need RCE squared. So this is 8e negative 4. And so I've converted my charges to coulombs, and I've converted the distance to, ultimately RCE squared is meters squared. This is square meters, so this is now in the appropriate units. It's in square meters. And so if I write this all or type this all into my calculator, I'm going to do that real quick. I get 135 newtons. So now I know the magnitude. Once I know the magnitude, okay, now I can go through and I can figure out the components. So to get the components, of course, you need to know the angle. The great thing is this vector is pointing right along with this side of the triangle. And this side of this, you probably already noticed, this is an isosceles right triangle that I have set up here. Let me... This triangle here, that last line isn't perfect, but it'll do. This is an isosceles right triangle. And so that means this angle here, and for that matter, this angle, they have to both be 45 degrees. But the important one is this one here. This side is 45 degrees to the horizontal, which means this vector is 45 degrees to the horizontal. This angle here is 45 degrees, okay? And so that means if I want the x component, then I know that FCEX has got to equal FCE times, let's see, so I want the cosine to get the x component, it's going to be the cosine of 45. And of course, if I want the y component, it would be the sine of 45. And so that's just going to be 135 times cosine of 45. And that's 95, what happened here? There we go. 95.459 newtons. And this one, and I should point out, I was a little hasty here, this angle is pointing down and to the right. It's pointing in the fourth quadrant, because down and to the right is the fourth quadrant. So that means negative y, so I should put a minus sign here. Okay. And so FCEY is going to end up equaling negative 95.459 newtons. So I've got my x and y components for FCEX. For FDE, that vector, you can see here, these are opposite polarities, and so there's going to be an attraction. So that force is going to be pointing this way, straight to the left. I'm going to leave it for you to get the components for that one. Once you've got your components, though, you know what to do. You need to, because you're trying to get the net force. So the net force, if I want the net force, that means I've got to add FCE plus FDE. That'll give me the net force on E. And that means I have to add the components, the like components. So it means I'm going to add FCEX to FDEX. And then I'm going to add FCEY to FDEY. And doing those two summations is going to give me FNetX and FNetY. Once you know the components, you should be able to get the magnitude and direction for your vector. This is just straight vector math here that we're doing. And this is case 3. Case 4, very similar to case 3, with one difference. QC is 4 microcoulombs. Here, you can see. Now, if we go back up here, QC was negative 4 microcoulombs. So once again, kept the magnitude of the charge the same, just changed the polarity. So change the polarity of this charge. That's going to change the net force as a result, because the polarity has changed. So you'll need to go through and do a similar analysis to what we were doing up here. There will be some similarities. Sometimes, if you're paying attention, you won't have to redo all the calculations, just some of them. I should be able to reason through it. But if you want to do all the calculations again, that's fine too. It's not like that's wrong. I'm just pointing out it's possible to think about what's going on and save yourself some computations. There are some questions at the end. I'll leave those to you to answer. And of course, if you do have any questions, if something hasn't been made totally clear by this video, that's fine. Reach out and ask. We're happy to answer questions. I hope this video does help. But if it doesn't answer all your questions, that's okay. Again, reach out and please ask.